Hi everyone, welcome to this lecture. So in this lecture, we are going to solve a numerical example on KNN. So this is my data set for the numerical example on KNN. So in the first column, we have the height of the customer. Then in the second column, we have the weight of the customer. And in the third column, we have a t-shirt size. So this data set is about the t-shirt size. We can see that in a t-shirt size, we have two kinds of labels, that is M and L. So this column is our label of the data set, or this is our target variable. Now, these are the heights of the customer and these are the weight of the customer. So based on the height and weight of the customer, we will decide about the size of t-shirt. For instance, if the height of the customer is 158 centimeter and weight is 58 kilograms, then we will assign a medium size t-shirt to that customer. Similarly, if we are here, if the height of the customer is 160 centimeter and the weight is 64 centimeter, in that case, we will recommend the large size t-shirt to the customer. So this is the t-shirt dataset. Based on the height and weight of the customer, we recommend the size of the t-shirt to the customer. Now, a new customer, Sarah, has height 161 centimeter and weight 61 kg. What size of t-shirt she needs? It means this is our new data point and the coordinates are 161 and 61, where 161 is the height in centimeter and 61 is the weight in kg. Let's check whether this point is present in our data set or not. So if we go back, we can see that this 61, which is the weight, is present at two different places in our data set, but 161 is not present in our data set anywhere in the height column. It means this is a totally new point and we have to apply KNN in order to recommend the size of a t-shirt to the new customer. So what we will do? So we will apply KNN algorithm, and here are the first two steps of the KNN algorithm. So we have decided to take the value of k is equals to 5. That is, we have decided to take the nearest neighbors is equals to 5. The second step is that we have to find the Euclidean distance of this new point with all the points in our data set. So we will start with the first point. This is our new point and this is our first point. These are the coordinates of new point 161 and 61, and these are the coordinate of our first data sample 158 by 158. If we go back, we can confirm that this is our first data sample. So we can see that our first data sample has height 158 and weight 58. Now it's time to calculate the distance of this new point with every point which is present in our data set. We know that this is our Euclidean distance. In Euclidean distance, we subtract the x coordinate from the x coordinate and y from the y coordinate. That is, we will subtract 158 from 161, then we will take square. Then we subtract 58 from 61, then we will take square. We will add them and we will take the square root. So here is the distance of a new point with the first data sample. Similarly, we calculate the distance of this new point with the second, with the third, and with all the points present in our data set. So here are all the distances. If you see, there is an additional column in the dataset known as a distance. So that is the distance which we have already seen now. This is a distance of a new data point with our first point whose coordinates are 158 by 58. Similarly, this is a distance of a new data point with the second sample. This is the distance with the third sample. This is a distance with the fourth sample. And similarly, this 7.3 is the distance with the last sample. Now, these are all the distances of our new data point with the existing point that are present in the data set. Now, in order to select the 5 nearest neighbor, find the 5 smallest distance. So if we see 1.4, 2.2, 2.2, 2, 3.2, they are the 5 smallest distance of a new data point with the data points that are present in the original data set. So these 5 distances, or those points which have these 5 distances with our new points, will constitute the nearest neighbor for the new data set. So this is the most closest point, then is this point, then these 2 points have the same distances. So that's why we call it 3, or we can also call it as a 3 and 4. And this is our 5th neighbor. So based on the 5 nearest neighbor, let's check the label and decide on the base of the majority voting. So basically here we are going to perform the step 3 and step 4. So step 3 is to select the nearest neighbor, and step 4 in KNN algorithm is to decide about the class based on the majority voting. So if we see inside the 5 nearest neighbor, we have 4 labels related to the medium size t-shirt. So based on the 5 nearest neighbor, we have decided that the size of a new customer is a medium size, and we will recommend a medium size t-shirt to a new customer whose height is 161 centimeter and weight is 61 kg. Okay, let's see what will happen if we increase the number of nearest neighbor from 5 to 7. So if we select 7 nearest neighbor, we can see that here we have select the 7 minimum distances. So if we select 7 nearest neighbor, in that case, if we go on the majority voting, still there are 5 samples out of 7 which belongs to medium class, and there are only 2 samples belongs to large class. So still in 7 nearest neighbor, we still recommend the size of t-shirt as a medium. So if we increase the nearest neighbor size further, and improve and increase it to 9 nearest neighbor, in that case these are the 9 nearest neighbor. So if we see the labels and if we go for the majority voting, so we have 6 labels which are related to the medium class, and there are 3 labels related to the large class. So based on the majority voting, we can see that we will recommend a medium size t-shirt to a new customer, Sarah. So we can see that whether our nearest neighbor is 9, 7 or 5, the majority voting tells us that the size of a t-shirt for the new customer is a medium size. So in this lecture, we learn how to implement KNN algorithm on some real value problem. We select a numerical example, and based on the KNN algorithm, we decided that the size of t-shirt for a new customer should be a medium size t-shirt. So I hope you understood this numerical example. Thanks for listening, and I will see you in the next lecture.